Namaste everyone. So till now we studied surface area and volumes, that is 13.1, 13.2 and 13.3, where we learned surface area, how to find the surface area and volume when combination of 3D figures are given. So now this is the last topic for you, that is called the new 3D figure, that is frustum of a cone. So which you never learned till now. Let me introduce what is the area, that is CSA, TSA and volume of this frustum of a cone. So before I explain all the formulae, let me introduce how this 3D figure looks and from what 3D figure you get this frustum of a cone. First of all, as you know, this is a cone. So when you cut a cone that is exactly at the middle, that is parallel to the base. So when you cut, this is a vertical point, as you know it is vertical point and it is a circular base. So when you cut the cone parallel to the base and when you remove this down part, so this looks like this, that is called frustum of a cone. So as you know, in a cone you have only one radius, so this is the radius. So when you cut from the cone, one portion of the cone from the bottom exactly parallel to the base, we get a frustum of a cone. So in this frustum of a cone, you can observe there are two circles, different circles, that is different radii. So this circle is smaller circle and this is a bigger circle. So let me explain what are the terms you have here, means what are the dimensions you have in this frustum of a cone. So from this edge to this edge, we call it as L, that as you know already it is called slant height. And this is nothing but height, which is also called as perpendicular height. So this is a perpendicular height and this is slant height, and as you know that two circles are different radii, so let me take this as R1 and this as R2. So R1 and R2 are interchangeable, you can take whichever you want as R1 and R2. So these are the three dimensions for this 3D figure, which we call this figure as frustum of cone. So let me show you one model for this. You can see this is a frustum of a cone. So if you imagine that a part of the cone is removed and the bottom part looks like this is called as frustum of a cone. So you can see that the base as circumference is bigger and for this circumference is small. So clearly I can tell that the radii of this base is greater than the radii of this. And from this edge to this edge, nothing but L, that is slant height. And from the center of the top circle to the center of the bottom circle, that height we call it as perpendicular height and we name it as H. And let me take the top circle as one more radius, that is R2, and here bottom circle as R1. So this is called frustum of a cone. So which is this 3D figure. Now let us, in this exercise we are going to learn overall about this, how to find area, how to find volume. So in area, as you know that there are three types of area. One is CSA and one is TSA. Two types. What is CSA of frustum? So when you take only this part, only you take leaving the top circle and the bottom circle, when you say take the lateral surface, we call it as curved surface area. Means I want to find now only this part. So what is the CSA of frustum? Pi into, as you know the CSA of cone is pi RL. So here you have two radii, so CSA of frustum becomes pi into R1 plus R2 into L. So I have to remember pi into R1 plus R2 into L is the CSA of the frustum. Next, coming to TSA. So as you know, there are three surfaces for this frustum. That is, this is one surface and the top one is another surface and this is another surface. Why I am telling this and these are two different surfaces? Because the radius of this circle and this circle are different. So the circular part is one surface and this is the another surface and this is a third. So there are three surfaces. So for TSA of frustum, I have to add the top circle area and the bottom circle area for CSA. So CSA is, first of all, as you know, pi into R1 plus R2 into L plus this circle, when you consider, it is called pi R1 square and this circle it is pi R2 square. That is called TSA of frustum. So I hope everyone are following. CSA of frustum is pi into R1 plus R2 into L and TSA of frustum is nothing but pi into R1 plus R2 into L plus both the circles area, top and bottom. Suppose Now like if I show you this is a tumbler where the base is closed and this is open. This is a glass. So this is open. So when I ask you to find the area of this glass, so what, not necessary that I have to add these two areas, that is circle. So what I have to add, CSA I have to take plus base area. So this top area is neglected. Why? Because it is open at the top. Suppose if it is open at both the ends, it comes only CSA. So if one end is open, that you have to consider. If both ends are closed, that you have to consider both. So it means add. If this is also closed and this is also closed, then this formula you get. When you want only this CSA, so you get this pi into R1 plus R2. So in this case here only one circle is open. So here pi 1 pi R2 square. This will not come. Only you will get pi R square. Only 1 pi R1 square you will get. Next comes volume of frustum. So what is the capacity of this frustum? Nothing but volume. So what is volume of frustum formula? 1 by 3 pi into R1 square plus R2 square plus R1 into R2 into H. Remember the cone formula 1 by 3 pi R square H. So here in place of R square you have to remember R1 square plus R2 square plus R1 into R2 into H. Next, as you know, in case of cone, the slant height formula L is root of H square plus R square. But here slant height L is root of H square plus R1 minus R2 whole square. Remember, and here I have written R1 is greater than R2. So in this figure I have taken R1 is greater and here R2 is smaller. So I have taken R1 minus R2. Suppose when you come across the questions where the other one is bigger, always you remember in this bracket you take bigger radii minus small radii whole square. Even if you take wrong also, you won't get wrong answer because you have whole square it is, no problem. R1 minus R2 whole square. So these are the three formulas along with slant height you have to memorize daily to understand that is frustum of a cone. Now let us start exercise 13.4. So all of you please be ready with your textbook and read the question now. Question is, first question, that is a drinking glass is in a shape of a frustum of a cone of height 14 centimeter. The diameter of its two circular ends are 4 centimeter and 2 centimeter. Find the capacity of the glass. What is meaning of capacity? Capacity is nothing but it is a volume. So how much water I can fill in this tumbler? That is nothing but capacity. So that is the space inside the glass. So now I have to find the volume of this glass. As you see here, only the base is closed and the top is open. And one thing remember children, whenever it is closed or open, in case of volume, the volume remains same. Either it may be open or closed. The formula remains same. The formula of volume or capacity will not change when any 3D figure is open. Remember this. So here it is open but the volume remains same. So what is the capacity of the glass? Frustum 1 by 3 pi h into R1 square plus R2 square plus R1 into R2. So what we need for these dimensions? We need h and we need r. So we don't want L here. So h is given, that is from here to here h is what? 14 centimeter, that is given h. And R1 diameter D1 and D2 diameters are given. So D1 is greater diameter, that is 4 centimeter, and if diameter is 4, radius will be 2. So this will be 2 centimeter and this is smaller than this, so it will be diameter D2 is 2 centimeter and R2 becomes 1 centimeter. This is R2 and this is R1. So we have all the three dimensions now. We can find the capacity of the frustum of cone. So let me start. Capacity of the glass, that is volume, equals to 1 by 3 pi h into R1 square plus R2 square plus R1 into R2. Just substitute all the values. 1 by 3 pi value. Unless he give 3.14, you please take pi value as 22 by 7. So into h is 14 and R1, I said already R1 and R2 can be interchangeable. Nothing that you have to take R1 this only, R2 is this. So you can take R1 and R2 as you wish. However you are writing the diagram, according to that you can take R1 and R2. So R1 square, R1 is 2, R2 is 1. 2 square plus 1 square plus 2 into 1. Overall in this bracket 2 square is 4, 1 square is 1, 4 plus 1 and plus 2 is 2 ones are 2. So total you will get 7. and you can cancel your 7 2s are 14. So you got 1 by 3 into 22 into 2 into 7. So multiply all this numerator, 22 into 2 into 7, we get 308 divided by 3. Because it is volume, what is the unit? Centimeter cube. If it is meter, you write meter cube. If it is centimeter, you write centimeter cube. And I did cancel this. So as you know that you learned in last year, whenever you have denominator 3, 7 or 11, any number other than 2 and 5, you get non-terminating repeating decimal. So better you keep in a fraction or you can keep in a mixed fraction. 308 divided by 3 centimeter cube. Now let us continue with the second question. The slant height of a frustum of a cone, that is L. Slant height is L and perpendicular height is H. Slant height is given 4 centimeter and the perimeters. What is meant by perimeter? In case of circle, they are boundary of the circle. That is nothing but circumference. Circumference of its circular ends are 18 centimeter and 6 centimeter. Just recall the formula of circumference of circle. What is circumference of circle? 2 pi r. But here we have two radii, that is R1 and R2. So 1 will become 2 pi R1. So what is circumference? You can see this boundary part is called circumference. So 2 pi R1 is nothing but 18 centimeter and this circumference 2 pi R2 is 6 centimeters. So given two circumference, that is the bottom circle and the top circle, and given the slant height L is 4 centimeter. And what is going to ask? Find the curved surface area of the frustum. So recall once what is the formula of CSA? CSA of frustum is pi into R1 plus R2 into L. Once if you see the dimensions, H is not given in the question. So is it necessary? No, not required. So we need L is enough now. R1 and R2 is given. R1, R2 is not given clearly, but the circumference is given. So with this, can I find R1 and R2? Yes, you can find. But is it necessary to find R1 and R2? Once you think. If you find R1 and R2, it becomes very lengthy because you have to substitute the pi as 22 by 7 in each case and you have to find R1 and R2. But why I am not finding R1 and R2? Just see here, I have taken 2 pi R1 is 18 and 2 and 18 gets cancelled, it becomes 9. So pi R1 I got 9 centimeter. I didn't substitute the pi value. I kept as it is. I'll tell you why I kept pi as it is. Pi R1 I got 9 centimeter. 2 pi R2 is given 6 centimeter. 2 ones are 2 3s are gets cancelled. Pi R2 is 3 centimeter. Now I have L as 4, pi R1 as 9 and pi R2 as 3. So what is CSA of frustum formula? Pi into R1 plus R2 into L. I hope that why I didn't substituted pi here. So because pi is common for both. If you multiply pi with R1, it will become pi R1. And when you multiply pi with R2, it becomes pi R2. So now I got pi R1 plus pi R2 and be careful that outside the bracket it is L. And as you know here pi R1 is 9, substitute. Pi R2 is 3, substitute. 9 plus 3 and L is 4. 9 plus 3, 12. 12 into 4, 48. So what is the CSA of frustum we got? 48. What is the unit? Centimeter square. So I hope instead of finding R1 and R2 when you find R1 and R2 and substitute also, you get the same answer. But why I didn't find? Because pi is common for both. It will be easy for me to get the answer. So some questions, if it is volume, there you have to find. But in this case, pi R1 and pi R2 terms you have in the formula. So without substituting pi value and without finding R1 and R2 separately, we got the answer. So we remember this will be for 1 mark question. So don't waste your time in finding R1 and R2. So very simple. Just find pi R1, pi R2 and substitute and find CSA. So CSA of this cone we got as 48 centimeter square. Now let us start third question. So given the cap used by Turks is in the shape like a frustum of cone. So as they said that there is a cap, so which is in this shape. Okay. If its radius on open side, so when there is a cap, just imagine, so if you want to keep a cap on your head, one side should be open. So he has given that where the cap is open, that radii is given 10 centimeter and its upper base is 4 centimeter and its slant height is 15 centimeter. Find the area of the material used for making it. So to make this cap, that is, which is a frustum of a cone, he has used the material to make this kind of cap. So for that, what we have to find, how much area of the material I have to use to make such kind of cap. So for that, what I have to consider, is it CSA or TSA? No. You can just observe the cap which is on the wider opening, that will be not closed, and this will be closed. Why? Because that whenever we keep the cap, that the opening which is of bigger area is opened and the smaller area is closed. So it is understood, and it is a common sense that one end of the cap is closed and one end, that is a bigger end, is open to keep on your head. And he has given clearly that which is shaped like a frustum of a cone, the radius on the open side, given open side radius means this is open, and the radius of that open side is 10 centimeter, and the closed side radius is given 4 centimeter, and the slant height is 15 centimeter. Now let me find the area of the material required to do this kind of cap, that is CSA plus pi R2 square. Once you observe, why I have to consider pi R2 square? Because it is closed. So this also we are using some material to stitch this. So this part is open, so I am not considering pi R1 square. So it is CSA plus one end of the frustum of cone where it is closed. So which end is closed? Clearly given in the question, and there you are stitching with that material only. That's why we have to consider pi R2 square. So overall formula is pi into R1 plus R2 into L plus pi R2 square. And as you know, here we know R1, R2 and L also. H is not required. So substitute, and be careful whenever you have common things. Take common and simplify. It will be very easy, because calculation is tough in this chapter. Try to do calculation by taking a common. So what you have common here? Pi and pi is common. So I am taking pi out. And when you are taking pi common, so here already small brackets you have, open the square bracket and write the remaining part in the square brackets. What is remaining? R1 plus R2 into L plus R2 square is remaining. Brackets are very, very important to simplify. So pi value is 22 by 7 and R1 is 10, R2 is 4 and L is 15. R2 is 4. Why I didn't take 10? Because 10 is open and 4 is closed. So that is 4 square. Now 10 plus 4 is 14. 14 into 15. So you get 210. 22 by 7 into 210 plus 4 square is 16. Add this, you get 226. 22 into 226 is what? 4972 divided by 7. As I already told, when you have a denominator other than 2 and 5, you can keep the answer in the fraction or in the mixed fraction. So 4972 divided by 7 centimeter square cloth or any material is required to make such kind of cap.